Hi, welcome to TechTube. My name is Daryl, and today I would like to discuss the impact that excessive board flex has on surface-mounted ceramic capacitors. I will begin by explaining what flex cracking is and show some examples of how flex cracking occurs. Next, I will show two ways to help determine if you have a flex crack. And then I will talk about how to reduce flex cracking by properly positioning the multi-layer ceramic capacitor on the circuit board. And finally, I will share some TDK crack mitigation solutions that are currently available. Let's begin. What is flex cracking? Flex cracking is a term used to describe mechanical cracks within the ceramic capacitor's body as a result of excessive board flexures after component soldering. Imagine a potato chip glued to a paper plate, where the chip represents the multi-layer ceramic capacitor, and the plate would represent the printed circuit board. If you bend the plate, the potato chip will break. Some ways in which a printed circuit board can experience flexures include installing circuit boards by snapping in place or screwing down the circuit boards into housings, plugging and unplugging cables or connectors on a printed circuit board after the components are soldered in, consumers having to repeatedly press buttons such as a key fob or control panel, or any other means which causes the circuit board to become subjected to bending and twisting. If a circuit board experiences a bend or twist, there is a danger that the tensile stresses can induce flex cracking on soldered components. This is especially true in multi-layer ceramic capacitors where ceramic by nature is brittle. Ceramics are strong in compression but weak in tension. If a multi-layer ceramic capacitor develops a crack, you can sometimes visually identify a discoloration on the surface. But more often than not, the flex crack appears under the terminations and hidden from sight. When a flex crack occurs, this weakens the dielectric and can create a lower path of resistance through the capacitor. This is reflected in a low insulation resistance reading. Flex crack avoidance can sometimes be accomplished by mounting brittle components parallel to the stress planes caused by board flexure instead of perpendicular. This requires an investigation, and although not always possible, avoiding harmful tensile stresses in this way is a good engineering practice. In addition to a smaller case size or a thicker body capacitor, TDK offers 4 different designs of multi-layer ceramic capacitors to address flex cracking. The first one is a TDK open mode design. A TDK open mode capacitor is designed to fail open as opposed to failing short. This design does not prevent the crack occurrence, but it does limit the risk of failing short. These illustrations compares a standard design to an open mode design, MLCC. The same board flex crack does not cross the active stack in an open mode design due to the larger gap between the terminals and the internal electrodes. This significantly reduces the risk of a short circuit in the event of a flex crack. Again, this will not prevent flex cracking, but will help to protect other components on the circuit by failing open instead of short. Another viable option in the multi-layer ceramic capacitor design arena is the TDK soft termination design. Here's an illustration showing the internal construction of a multi-layer ceramic capacitor with a soft termination. A soft termination capacitor has an extra layer of flexible conductive resin between the copper base and the nickel plating of each terminal. This flexible resin electrode helps absorb the stresses from the board flexure, directing the stress away from the ceramic body. A serial design ceramic capacitor is another solution to address flex cracking. Serial mode design multi-layer ceramic capacitors also come with a flexible resin electrode like the soft termination family, but this design contains 2 discrete capacitors in series in one ceramic body. In the event of a board flexure crack, the first capacitor would fail open, but the second capacitor remains operational. Since the active area is reduced in the serial design, the overall capacitance range is limited. This design is useful in battery line applications where 2 discrete capacitors are required. And finally, The MegaCap design utilizes a single or two capacitors stacked on top of each other and connected in parallel via a lead frame. This part was originally designed to double the capacitance in a given application requiring high capacitance and limited board space. However, the lead frame is a very effective stress absorber for both mechanical and vibrational forces, and customers often use MegaCaps for crack mitigations in areas of high board flex risk. MegaCap designs allowed for maximum board flexure robustness. Today I have explained what flex cracking is and shown some examples of how they occur. We have seen what flex cracking looks like on a multi-layer ceramic capacitor when they are improperly handled. To reduce the risk of flex cracking, keep multi-layer ceramic capacitors away from connectors and screw holes and keep them parallel to board edges. And finally, TDK offers several flex crack mitigation design solutions that are currently available. Please visit www.tdk.com for more information. Thank you for watching TechTube and stay tuned for future videos.